The ancient ocean was not a place, it was a process, a vertical system that punished hesitation and rewarded finality. As life descended into deeper water, it did not become more complex, it became more precise. Near the surface, the ocean allowed inefficiency. Light was abundant. Food chains were crowded. Mistakes could be corrected, but depth removed forgiveness. Every meter downward stripped energy from the system. Light vanished first, then warmth, then predictability. What remained was pressure, scarcity, and time. Not human time, geological time. And over millions of years, depth rewrote the rules of survival. At shallow depths, ancient marine ecosystems resembled competition. Predators chased, prey fled. Encounters were frequent, but not always final. In these environments, speed mattered, vision mattered, agility mattered. But as organisms moved deeper, the environment stopped supporting movement. Water thickened under pressure. Muscles worked harder. Energy expenditure increased. Chasing prey became inefficient. Failure became fatal. In deep water, a predator that missed too often did not adapt. It starved. Evolution responded accordingly. Depth transformed the ocean from a battlefield into a filter. Only organisms capable of ending encounters quickly survived, not through aggression, but through inevitability. Deep water predators did not evolve to fight. They evolved to conclude. The deeper ancient creatures lived, the less often they encountered food. The scarcity reshaped anatomy. Jaws widened, not for intimidation but for certainty. Teeth thickened, not for tearing but for crushing. Some predators evolved mouths large enough to engulf prey whole, because injuring prey was not enough. Others developed bone-crushing bite forces, capable of shattering armor that had evolved precisely to resist them. This was not escalation for dominance. It was escalation for efficiency. Light loss forced another transformation. Vision, once dominant, became unreliable. Eyes enlarged at first, then became secondary. Some species abandoned sight entirely. Instead, pressure waves, vibrations, and chemical detection took over. Predators learned to feel prey before seeing it. The ocean became a dark, mechanical system where movement itself was a signal. Any disturbance was noticed, and noticed meant targeted. As depth increased, prey species adapted defensively. Shells thickened, spines multiplied, camouflage improved. But every defensive innovation came with a cost. Heavier armor meant slower movement. Slower movement meant vulnerability. Predators adapted again. Crushing replaced slicing. Suction replaced biting. Ambush replaced pursuit. The arms race did not slow. It narrowed. One of the most critical changes occurred in metabolism. Near the surface, high-energy lifestyles were sustainable. Deeper down, energy budgets collapsed. This forced predators into low-frequency, high-certainty feeding strategies. They could not afford repeated attempts. They could not afford drawn-out struggles. An attack either succeeded completely or ended the predator's future. This pressure eliminated indecisive designs. What survived were bodies optimized for a single decisive action. Ancient deep-sea predators began to resemble tools rather than animals. Skulls fused for strength, necks shortened to prevent damage. Muscle attachments thickened to maximize force. Flexibility decreased. Durability increased. These were not animals built to live long lives. They were animals built to survive long enough to reproduce. Anything beyond that was irrelevant. Depth also altered time perception within ecosystems. Growth slowed. Reproduction slowed. Recovery slowed. Injuries that might heal near the surface became permanent below. A damaged jaw did not heal quickly. A torn fin did not regenerate efficiently. This punished experimentation. Only designs that minimized damage survived. The ocean did not tolerate fragile success. At these depths, evolution stopped favoring versatility. It favored commitment. Predators specialized so completely that they became dependent on specific prey behaviors. They waited, They blended. They conserved energy for long periods, and when opportunity appeared, they ended it instantly. This is where the misconception begins. For a long time, deep water predators were assumed to be slow, primitive, or passive. This assumption was based on surface logic, but fossil evidence contradicts it. Ancient prey species found at depth show damage patterns that indicate sudden, catastrophic attacks. No prolonged struggle, no repeated injuries, single-point failure. This suggests not slowness, but precision. Depth did not make predators lazy. It made them exact, because in the deep ocean, approximation equals extinction. What emerged from these pressures was not monstrous behavior, but mechanical behavior. Predators became systems. They waited, calculated, and acted once. And when they acted, the encounter ended. This is the foundation of deep-sea deadliness. Not aggression, not cruelty, not dominance, but inevitability shaped by environment. And the deeper life went, the more the ocean demanded final answers. By the time ancient life crossed into true deep water, the ocean stopped behaving like an ecosystem and began behaving like a constraint system. Here, depth was no longer a location. It was a condition imposed on everything that entered it. Pressure increased relentlessly. Every 10 meters added force. Every 100 meters multiplied it. At depth, water was no longer neutral. It pressed inward, compressing gas-filled organs, reshaping soft tissue, and punishing any structure not designed to resist collapse. This was not a place where weak anatomy survived long enough to adapt. It was a place that erased it. One of the first things depth removed was vertical escape. Near the surface, prey could flee upward or downward. In mid-water, escape paths were three-dimensional. At extreme depth, those options vanished. Ascending too quickly risked pressure damage. Descending further increased metabolic cost and physical strain. Movement itself became dangerous. The ocean trapped organisms inside a narrow, survivable band. Within that band, predators learned something critical. Once prey entered the wrong depth layer, it could not easily leave. This transformed hunting. Predators no longer needed to outrun prey. They only needed to control space. Ancient deep-water predators positioned themselves along depth boundaries, zones where pressure, temperature, and oxygen shifted abruptly. Prey crossing these boundaries experienced stress, slowed reactions, impaired movement. Predators exploited this. They did not chase. They waited at thresholds. When prey crossed, escape options collapsed instantly. This was not ambush as aggression. It was ambush as inevitability. Depth also altered oxygen availability. In ancient oceans, oxygen was unevenly distributed. Some deep zones were starved of it entirely. Low oxygen environments punished sustained activity. Prey adapted by slowing metabolism. Predators adapted by minimizing exertion. This forced a shift from pursuit to precision. Every movement mattered. Every muscle contraction cost energy that might not be recovered. Predators evolved to strike once and end the encounter completely. The deeper predators, the less tolerance they had for prolonged violence. Extended struggles risked exhaustion. Exhaustion meant death. So biology adapted. Muscle fibers became thicker, shorter, and more explosive. Jaws locked with greater force over shorter distances. Instead of slicing repeatedly, predators crushed, snapped, or engulfed. Encounters ended in seconds. Not because predators were fast, but because prey had nowhere left to go. Depth also removed sensory redundancy. Near the surface, vision, sound, and movement all provided information. Deeper down, vision collapsed. Light became scarce, then absent. Predators that relied on sight alone failed. Those that survived developed alternative detection systems. Pressure-sensitive organs detected minute disturbances. Chemical receptors tracked faint traces of biological activity. The ocean became readable through vibration rather than sight. Movement itself became a liability. A drifting organism disturbed water. A struggling prey amplified signals. Predators did not need to see. They only needed confirmation. This sensory shift made deep predators more accurate, not more aggressive. They waited until detection thresholds were crossed. Then they acted. No warning, no pursuit, just execution. As prey adapted defensively, the environment limited how far those defenses could go. Armor thickened, but weight increased. Spines grew, but maneuverability decreased. Camouflage improved, but detection methods changed. Prey could not evolve speed without oxygen, could not evolve endurance without food. The environment constrained defensive options. The predators exploited these constraints. They did not need to overpower prey physically. They only needed to exploit the fact that prey was already compromised by depth. This is where deep-sea deadliness diverges from shallow water predation. Near the surface, predators and prey are both active participants. At depth, the environment joins the predator. Pressure restricts movement. Low oxygen slows reaction. Darkness removes warning. Predators do not fight alone. They fight with the ocean. Ancient fossils recovered from deep water sediments reflect this reality. Prey species show abrupt skeletal failure, crushed shells, snapped spines. Damage patterns indicate sudden application of force, not prolonged struggle. This contradicts earlier assumptions of slow, passive, deep predators. What it reveals instead is a system optimized for certainty. Predators do not waste energy on repeated attempts. They could not afford to. Depth also changed the consequences of injury. In shallow environments, injured animals could retreat, recover, and return. At depth, recovery was unlikely. Low metabolism slowed healing. Scarce food limited regeneration. A damaged predator was already dead. This forced anatomical robustness. Bones thickened, skulls fused. Vital structures were protected at all costs. Predators became difficult to injure because injury meant extinction. Over time, this filtered out anything fragile. Only designs capable of surviving repeated high-force interactions remained, not because they were dominant, but because they were resistant. Depth did not reward aggression, it rewarded durability. The deeper these ancient creatures lived, the more their survival depended on removing uncertainty. Predators that allowed prey to escape did not get another chance. Predators that hesitated did not survive to reproduce. Evolution selected for designs that ended encounters quickly, reliably, and with minimal energy loss. This is the core reason deep predators became deadlier, not because they were more violent, but because the environment made failure unrecoverable. By the time ancient life fully adapted to extreme depths, the ocean had completed its transformation. It was no longer a place where survival involved repeated chances. It was a place where survival depended on single outcomes. And in such systems, deadliness is not a trait, it is a requirement. As predators adapted to depth, prey did not remain passive. Survival forced response. In ancient deep oceans, prey species began reinforcing themselves in the only ways available. Shells thickened, exoskeletons hardened, spines lengthened and multiplied. At first, these adaptations worked. Predators struggled to penetrate reinforced armor. Some attacks failed, but failure did not halt the arms race. It intensified it. Armor introduces weight. In shallow water, weight can be offset by buoyancy and speed. At depth, both are limited. As prey became heavy, movement slowed. Reaction time suffered. Prey could no longer rely on evasion. They relied on endurance. This was a mistake. Depth does not reward endurance. It rewards resolution. Predators responded by abandoning slicing and tearing entirely. These methods require repeated contact. Repeated contact wastes energy. Repeated contact increases injury risk. Instead, predators evolved crushing mechanisms. Broad jaws capable of generating extreme force. Reinforced skulls designed to absorb impact. Teeth that did not pierce but pulverized. Crushing ends resistance. Shells that deflect cutting fail under compression. Bone breaks. Armor collapses. What was once protection became a liability. Some predators evolved molar-like teeth designed for repeated compression. Others developed beak-like structures capable of snapping reinforced shells cleanly. In certain species, the entire head became a hammer. Necks shortened to prevent damage. Muscle attachment sites expanded. These were not animals built for flexibility. They were built for force transmission. Depth also changed how predators evaluated prey. Near the surface, predators could afford to test defenses. At depth, testing cost energy. Predators evolved the ability to assess prey viability instantly. If resistance exceeded expected thresholds, the predator disengaged. If resistance was within tolerance, the attack proceeded to completion. This selectivity improved survival. Predators did not gamble, they calculated. This is where deep-sea deadliness becomes misinterpreted as aggression. In reality, it was restraint. Predators did not attack everything. They attacked only what they could reliably end. And when they attacked, they committed fully. Prey attempted additional countermeasures. Chemical defenses intensified. Toxins became more potent, but chemical deterrence requires warning. At depth, warning systems fail. Predators did not taste prey before attacking. They destroyed it. Toxins became irrelevant when encounters ended in seconds. Some prey species attempted camouflage, flattened bodies. Coloration matched sediment. This worked briefly. Predators adapted again. Sensing shifted further away from vision. Pressure waves, electrical fields, chemical traces. Camouflage lost meaning. The environment itself betrayed prey. Depth punished generalists. Organisms that attempted multiple defensive strategies failed. Each strategy required energy. Energy was scarce. Only specialists survived. This applied to predators as well. Predators that attempted versatility died. Those that committed fully to one hunting strategy survived. The ocean filtered relentlessly. Fossil records from deep sediments reveal this narrowing. Species diversity decreases with depth, but lethality increases. The few predators that remain are disproportionately destructive, not because they are dominant, but because they are optimized. One critical misconception must be addressed. Deadliness does not mean constant violence. Deep predators spent most of their existence motionless. Energy conservation was essential. Violence was rare, but when it occurred, it was final. This pattern is visible in damage analysis. Prey fossils show catastrophic failure, not prolonged injury. Single crushing events. No evidence of escape attempts. No repeated damage. This is why deep predators appear more lethal, not because they killed more often, but because survival demanded that killing, when it occurred, was absolute. The arms race eventually reached a limit. Prey could not increase armor indefinitely. Weight increased metabolic cost beyond survivable thresholds. Predators could not increase force indefinitely. Structural integrity had limits. At this point, depth selected winners and erased the rest. Entire lineages disappeared, not because they were inferior, but because the environment moved beyond what they could sustain. This extinction pattern is critical. It shows that depth does not favor dominance. It favors adequacy under constraint. Predators that were too specialized vanished when conditions shifted. Prey that relied on armor alone vanished when predators adapted. The ocean does not preserve advantages, it replaces them. By this stage in ancient ocean, deadliness was no longer escalating rapidly. It had stabilized. Predators were as deadly as necessary, no more, no less. The system had reached equilibrium under pressure, darkness, and scarcity. This equilibrium was fragile. When oxygen levels changed, when currents shifted, when temperature gradients altered, the balance collapsed, and the ocean selected again. Understanding this arms race clarifies the central question. Ancient ocean creatures did not become deadlier because they were monstrous. They became deadlier because depth removed alternatives. When escape disappears, when recovery becomes impossible, when energy is finite, biology converges toward certainty. This is the logic of depth, and it does not negotiate. For much of modern study, deep water predators were assumed to be slow, low oxygen, low temperature, low metabolism. From the surface, this logic appears sound. But the fossil record does not support it. What it reveals instead is something more unsettling. Depth did not slow predators. It removed the need for speed. Speed is a solution to uncertainty. Near the surface, predators chase because prey can flee. Speed compensates for unpredictability. At depth, unpredictability collapses. Environmental constraints narrow outcomes. Pressure limits vertical movement. Darkness removes warning. Scarcity restricts opportunity. Predators did not need to move fast. They needed to move correctly. This distinction is critical. Deep predators did not evolve for pursuit. They evolved for compression. Reaction time shortened not through faster muscles, but through reduced decision trees. There were fewer options. When prey entered a detection threshold, the response was immediate, not fast in distance, fast in commitment. Pressure altered muscle behavior. Shorter muscle fibers generated force more efficiently over small distances. These muscles were not designed for sustained movement. They were designed for explosive action. Single contractions, single outcomes. This is why fossil damage patterns show catastrophic failure rather than cumulative injury. Depth also punished hesitation. Near the surface, a missed strike might still allow retreat. At depth, missed strikes cost energy that could not be replaced easily. Predators that hesitated starved. Those that committed survived. This selected for neurological pathways that favored immediate execution over evaluation. Decision-making simplified. Stimulus crossed threshold. Response triggered. No deliberation. The environment did not reward intelligence in the human sense. It rewarded reliability. Predators that responded consistently to the same conditions outperformed those that experimented. Depth compressed behavior. Ambush became the dominant strategy, not because it was clever, but because it was efficient. Predators positioned themselves where prey density increased. Thermal layers, pressure gradients, chemical boundaries. Prey crossing these zones were already stressed. Reaction times slowed. Muscle efficiency dropped. Predators did not need to overpower prey. They needed to intercept it at its weakest point. This is why deep predators appear lethal without appearing active. They waited, sometimes for days, sometimes longer. Energy conservation was survival. Movement was risk. Stillness was strategy. When the strike occurred, it was brief. No chase, no struggle, no prolonged violence, just termination. This pattern explains a major misconception. Observers assume lethality requires activity. At depth, lethality emerges from absence of movement. Predators were deadly precisely because they did not move unless success was assured. The deeper these ancient creatures lived, the more compressed their hunting window became. Opportunities were rare. Failure could not be repeated. This produced predators that attacked less frequently, but with greater certainty. Deadliness was not about frequency. It was about finality. Pressure also altered prey behavior. Prey at depth could not afford panic. Sudden movement increased detection. Fleeing blindly increased pressure stress. Many prey species adopted slow, deliberate movement. This made them predictable. Predictability is fatal in constrained systems. Predators learned patterns. They learned timing. They learned thresholds. Depth removed randomness, and randomness protects prey. Another belief must be dismantled. Deep predators were not primitive. They were refined. They represent endpoints of evolutionary narrowing. Everything unnecessary was removed. Only functions directly tied to survival remained. This made them appear alien, not because they were monstrous, but because they were efficient beyond surface standards. In surface ecosystems, redundancy protects survival. Multiple senses, multiple behaviors, multiple escape routes. At depth, redundancy wastes energy. It was eliminated. Predators became singular in purpose. Fossil evidence supports this. Deep predators show reduced morphological variation. They converged on similar designs despite different origins. Wide jaws, reinforced skulls, compact bodies. Convergent evolution is a signal. It indicates that multiple evolutionary paths reached the same solution. Depth did not allow creativity, it allowed adequacy. This convergence also explains why deep predators feel unfamiliar. They do not resemble surface animals. They resemble tools, built for one task, executed repeatedly. By this point in ancient ocean, deadliness was no longer escalating dramatically. The system stabilized. Predators killed efficiently. Prey died quickly. Energy flowed through narrow channels. The ocean became quiet, not peaceful. Controlled. This is the culmination of depth-driven evolution, not chaos, but inevitability. Understanding this reframes the original question. Ancient ocean creatures did not become deadlier because depth made them aggressive. They became deadlier because depth removed alternatives. When escape disappears, when recovery vanishes, when opportunity is rare, biology converges toward certainty, and certainty is lethal. The ancient deep ocean did not preserve its deadliest creations. It replaced them. Depth created predators that were precise, efficient, and final. But precision has a weakness. It depends on stability. The same constraints that forged deadly specialization also removed flexibility. Deep predators evolved for narrow conditions, specific pressure ranges, specific oxygen levels, specific prey behaviors. They were not adaptable in the way surface predators were. They did not need to be. For millions of years, the deep ocean remained relatively stable. Then it didn't. Ocean chemistry shifted. Oxygen distribution changed. Currents reorganized. Thermal layers moved. Food webs restructured. These were not catastrophes in a dramatic sense. They were gradual. And gradual change is the most lethal force for specialists. Deep predators could not simply migrate upward. Pressure differences were physiologically incompatible, nor could they diversify their diet easily. Their anatomy was optimized for one outcome. Crushing jaws could not slice softer prey efficiently. Ambush strategies failed when prey distribution changed. Energy budgets collapsed. Predators did not starve dramatically. They simply stopped reproducing. This is how most ancient deep predators disappeared, not through violence, through irrelevance. Fossil records show abrupt absences. Entire lineages vanish without transitional decline. This suggests extinction not through competition, but through environmental mismatch. The ocean did not punish them. It outgrew them. This is a critical reversal of perception. The deadliest predators were not the most resilient. They were the most constrained. Their effectiveness depended entirely on a narrow set of conditions. When those conditions shift, deadliness became useless. Depth did not reward dominance long term. It rewarded adequacy under specific constraints. Once those constraints changed, the advantage inverted. Prey species adapted more easily. Some shed armor. Some migrated shallower. Some diversified diets. Generalists survived. Specialists vanished. This reveals an uncomfortable truth. Deadliness is not an evolutionary endpoint. It is a temporary solution. The ocean does not care how effective a predator once was. It does not preserve past success. It responds only to present conditions. This is why Earth must be treated as the protagonist of this story. Not predators. Not prey. The planet sets parameters. Life responds. When parameters change, responses that once worked are discarded. Ancient deep predators feel frightening because they represent what happens when environments become unforgiving. They are not warnings by intent. They are records. Records of how life behaves when margins disappear. Modern oceans are changing again. Oxygen minimum zones are expanding. Thermal layers are shifting. Food distribution is altering. Depth boundaries are moving. These changes are not identical to ancient conditions, but the pattern is familiar. If environments become more constrained, life will respond as it always has. Not ethically, not gently, mechanically. The scariest implication is not that ancient predators were deadly. It is that deadliness emerges automatically under constraint. No intelligence guides it. No morality limits it. The system does not ask permission. Earth has done this before. Multiple times. in multiple oceans, using different creatures with the same logic. Depth is not a place, it is a filter. And when environments filters remove flexibility, what remains is precision, and precision is lethal. There is no guarantee that future oceans will recreate these exact predators. Evolution does not repeat designs, but it does repeat processes. If conditions demand finality again, life will answer, not with monsters, with mechanisms. And when those mechanisms are no longer useful, they will be erased, without ceremony, without memory. The ancient deep ocean did not create killers because it wanted to. It created them because it had no room for anything else. That is not history, that is pattern.